Ma'am, can you show the last question?
Yeah, just a minute. I'm just starting the recording. Yeah. Yes, children, I'm here. Good evening, children.
Good evening, ma'am.
Good
You
evening,
students,
ma'am.
good evening, children. Good evening. Is Shivam here? Yeah, hi, good evening. Shivam, Surya, and Yarini. Uh, you were able to
Yes,
join the
ma'am. Good
meeting
evening, ma'am.
comfortably? Surya,
Yes, ma'am.
Shivam, and Yarini? Okay, that's nice.
Yes, ma'am.
Very nice. Okay, okay. Okay, so it's time to see the answer to question number 2. The question is, please stop working, children. We'll discuss the answers. I think you should finish 2, 3, and 4 at least, right?
Yes, ma'am. Even 5 is over.
Okay, so that's nice. Okay, so we'll see the answer to question number 2. Yeah, the question is, the area of a square park is 4 hectares. The area of a square park is 4 hectares. Well, we know that 1 hectare is 10,000 meters square. 1 hectare is 10,000 meters square. So 4 hectares will have an area of 4 into 10,000, 40,000 meters square. The area of the square park is 4 hectares. 4 hectares. The short for hectares is HA, not HE. The short for hectares is HA and not HE. Like kilometer is km, meter, liters, milliliters. Hectares is HA, not HE. So the area of the square park is 4 hectares, which means it is 4 into 10,000, 40,000 meters square. So this is the area of the square park in meter square. So that's the first sub question. Express the area in meter square. So 40,000 meters square. Then you need to find the perimeter of the square park in meters. The perimeter in meters. We need to find the first part of the question we have answered. The first sub question we have answered. We need to express the area in meters square, and we have done it. The second sub question. Find the perimeter of the square park in meters. To find the perimeter, the formula is 4 into side. 4 into side. So you need to know the length of the side of the square park. We don't have that. But what do we have? We have the area of the square park. And we know that the square root of area is a side. Side of the square park will be the square root of area. So that is square root of 40,000, which is the square root of 4 is 2. And from 4 zeros, 2 zeros will come out. So the side of the square park is 200 meters. I'll show the complete, you will see all the steps in the next slide. I'm just explaining before I show the slide to you. Side is equal to square root of area. Square root of 4 is 2. And from 4 zeros, 2 zeros come out. So the side of the square park is 200 meters. Now the perimeter is 4 into side. 4 into 200, which is 800 meters.
Ma'am, I got the same answer.
Very good.
Yes, ma'am. Me too. Yes, ma'am.
Very nice.
Ma'am, even I got the same answer.
Very good. So you can see here. 1 hectare is 10,000 meters square. So 4 hectares will be 4 into 10,000 meters square, which is 40,000 meters square. So the area of the square park is 40,000 meters square. What is the formula to find the area? Side square. So area is 40,000. That means the side square is 40,000. So side is equal to the square root of 40,000, which is 200. Because the square root of 4 is 2. And from 4 zeros, 2 zeros out of the square root. So the side of the square park is 200 meters. Now the perimeter of the square park, the formula is 4 into side units. 4 into side units. So 4 into 200, which is 800 meters. In case you've gone wrong in calculating something, please take a screenshot and you can correct your answer later. Take a picture of the slide, take a screenshot. Okay, next one. Anyone wants to share the answer to this question?
Ma'am, can I answer?
Yes, Anitika?
Ma'am, so I did the prime factorization method.
What is the
And
LCM?
ma'am,
Yeah,
I
what's the
got it
LCM of
as
the four numbers?
LCM.
No, you need to first. No. Okay, you don't. I don't want the meaning. What are the prime factors you got for the LCM?
5, 2, 3.
5 into 2 into 3.
No, 2 5s, 3 2s, and 1 3.
Oh no, I didn't get it. 1 minute. Sorry. Come again.
2 5s,
Yeah.
3 2s,
Okay.
and 1 3.
All right. Okay. So what's the required number? So this is the LCM of the four numbers. All right. And what is the required number? The final answer.
Ma'am, I got 60.
Ma'am,
60. Yes, Gayatri?
can I?
Yes.
Ma'am, I got 3,000.
Yeah,
Yes, ma'am.
Gayatri?
300, ma'am. 3,600.
3,600. Okay. Did you get these factors for the LCM, Gayatri?
Yes, ma'am. And I
Very good.
multiply each with itself, ma'am.
Okay. So the final answer is 3,600, right?
Yes, ma'am.
Okay. Anintika, you said 60?
Yes, ma'am.
Okay. Let's see what is right. 3,600. Yes, Gayatri, you're right. Very good.
Thank you, ma'am.
Ma'am,
Anintika. Yeah. Anintika.
Square root.
Sorry?
Took the square root, like 5 into 5 square root, like that.
Okay. Fine, children. So what is the procedure? I told you. You need to find. See, we have done a similar question in the last class. This question is not new to you. A similar question with three numbers. A similar question with three numbers we had done in the last class. Okay, what is the question? We need to find the least square number. Least, smallest square number exactly divisible by 10, 15, 24, and 50. So we'll first find the smallest number. We'll not find the smallest square number first. We'll first find the smallest number. Least number meaning we'll first find the smallest number. And we know that the smallest number exactly divisible by these four numbers will be the LCM of the four numbers. The smallest number will be the LCM of the four numbers. And we know how to find the LCM of the given numbers by the prime factorization method. And that's what you see here. That is the procedure you see here. And you're all aware of this. So perform this procedure. Perform this procedure. And you don't have to mention LCM. The smallest number exactly divisible by the four numbers is equal to 2 square into 2 into 3 into 5 square. You don't have to mention LCM here because the question is not to find the LCM, but we have to work that procedure to get the required answer. So step 1, take up the four numbers and perform the procedure to find the LCM of these four numbers. After that, the smallest number exactly divisible by these four numbers is equal to 2 square into 2 into 3 into 5 square. Okay, so this is the smallest number, but it is not a square number. This is the smallest number, but it's not a square number. How can you say that it's not a square number? Because you can see this prime 2 does not occur in pairs. And also this prime 3 does not occur in pairs. So to make this number, see, this is an expression which represents a number, children. Okay, so this one is not a number. This one is not a number. This is an expression which represents a number. When you find the product, you will get a number. So now it's an expression that represents a number. Now this expression is not a perfect square because 2 and 3 do not occur in pairs. So how do you make it a square number? You need to introduce one more 2 and one more 3. So that 2 becomes 2 square and 3 becomes 3 square. The others are fine. This is 2 square, this is 5 square. The others are fine. Okay, only for those which do not occur in pairs. So there is this 2 alone, this 3 alone. So you need to make this 2 square by multiplying by 2 and this 3 square by multiplying by another 3. So you need to multiply by 6. So the next step, the required smallest square number. This is the smallest number. This is the required smallest square number. Smallest number, smallest square number. Smallest number, smallest square number. So to make it a square number, we're going to introduce a 2 and a 3. So that way it's going to become 2 this 2 square as it is. This 2 and this 2 becomes 2 square. This 3 and this 3 becomes 3 square and 5 square. And the product is 3600. So 3600 is the smallest number. No, is the smallest square number. The smallest number is the product of this one. 3600 is the smallest square number, exactly divisible by 10, 15, 24, and 50. And 3600 is a perfect square. Can anyone tell me the square root of 3600? What is the square root of 3600?
160.
60, because the square root of 36 is 6, and from 2 zeros, 1 zero out. But we don't have to find the square root of 3600. The answer is this one. This is the required number. And we know this is a square number. This is a perfect square because its square root is 60. For the new students, my screen should be visible to you. I have shared my screen. I'm talking with respect to my screen. So for the new students, my screen should be visible to you on your device. And my voice also should be audible. Not just audible, clearly audible. Kindly acknowledge Yarini. Yeah. Shivam and Surya.
Yes, ma'am.
Yes, ma'am, it's audible, ma'am.
And Yarini.
Yes, ma'am, it's clear for me, ma'am.
All right, good. All right, children. Again, if you have made any mistake here, please take a screenshot and work it later. Because we've already taken time to try these sums. Now I cannot again wait for you all to complete the answer, right? So you can take a screenshot and complete this before the next class. Okay. So in case you have some doubt here, let me just recall this for you. So we start with the smallest prime number. At least one of these numbers should be divisible by 2. Only then you can use a 2. At least one of these numbers must be divisible by 2. All the numbers need not be divisible by 2. At least only for HCF we do that. For HCF, the story is different. This is LCM. For LCM, at least one of these numbers should be divisible by 2. We always start with the smallest prime, 2, then we try 3, then 5, then 7 and 11 and so on. So we start with 2. And yeah, we have 10 and 10, 24 and 50 divisible by 2. It's enough if even one number is divisible by 2. So we start with 2. 2 5s are 10. 15 is not divisible. So write 15 as it is. If it's not divisible, write it as it is. 24 12 times and 50 25 times. Next again, you can take a 2 because there is this number 12 which is divisible by 2. So you can take 2 again. I told you at least one of the four numbers must be divisible by 2. So for the sake of 12, you can take 2 again. So 5 as it is, 15 as it is, because they're not divisible. So write them as it is. And then 12 is 6 times, 25 as it is. Now in this step, again, you can see 6 is divisible by 2. So I always start from the least prime. I'll not jump to 5 and then come back to 3. I'll not go to 5, 7 and then come back to 2 and 3. No, I always start from, I make sure that I don't make a mistake there. I always start from the smallest prime. So from 2, then I move to 3, then to 5, then to 7, and so on. Okay, so there is 6 again, which is divisible by 2. So 5 as it is, 15 as it is, 6 is 3 times, and 25 as it is. Now there is this 3, which is divisible by 3. And there's also 15, which is divisible by 3. Now 2 is not possible. After this, 2 is not possible. So next prime, 3. 3 not divisible. 5 is not divisible by 3. So write 5 as it is. 15 is 5 times. 3 ones are 25 as it is, not divisible. Now you should not take 3 here, because 3 is not divisible by any of these numbers. Sorry, none of these numbers, meaning I told you the other way. So none of these numbers are divisible by 3. None of these numbers are divisible by 3, so you cannot take 3. So the next prime, 5. 5 ones are, 5 ones are. If it's 1, write 1 as it is. If it's 1, so just write it as it is. And 5 fives are. And finally, 5 again. 5, 1, 1, 1, and 1. 5 ones are 5. So in case this you had, like forgotten this method, I've helped you recall that. Okay. Yeah. So what's the answer to this question? The number of students in the class?
Ma'am, 133.
Louder, Aishwarya?
Ma'am, 133.
133. Very good. Number of students in the class, 133. And what about the money contributed by a student?
Ma'am, I got the answer as 133. Same.
Okay, good, good. Aishwarya, and the money contributed by a student?
Ma'am, that's also 133.
That is also 133. Very good. Yeah. So let's understand this question. The students of a class arranged a picnic. Each student contributed as many rupees as the number of students in the class, which means if the strength of the class, if the total strength of the class is 30, then each student contributes 30 rupees. If the strength of the class is 50, each student contributes 50 rupees. If the strength of the class is 75, then each student contributes 75 rupees for the picnic. So whatever is the strength of the class, the same is the amount of money contributed by each student for the picnic. Okay, so the students of a class arranged a picnic. Each student contributed as many rupees as the number of students in the class. So whatever is the strength of the class, was the money also contributed by each student. So if the strength of the class is 45, if there are 45 students in the class, then each student contributes 45 rupees for the picnic. So like this, the total contribution is rupees 17,689. Like this, the total contribution, the total money collected from all the students is 17,689 rupees. With this information, we need to find the number of students in the class and the money contributed by each student. So if supposing the number of students in a class is X, the money contributed by them is also X. And how will you find the total contribution? X into X is the total contribution, which is 17,689. How many students in the class? We don't know. X. What is the money contributed by each student? X. Because whatever is the strength, the same is the contribution. Now, how will you find the total contribution? Number of students X into the money given by each, Number of somebody's mic is enabled. Please disable your mic. Yeah. So supposing there are X students, each one of them gives X rupees for the picnic. So how will you find the total contribution, number of students into the money contributed by each student? The product of this is equal to 17,689. Because if there are 20 students and each of them give 20 rupees, what is the total money collected? 400 rupees.
400.
Yeah. So that means X into X is equal to 17,689. X square is equal to 17,689. X is equal to the square root of 17,689. X into X is equal to 17,689. X square is equal to 17,689. X is equal to the square root of 17,689, which looks to be 133.
Yes, ma'am. That is an answer, ma'am.
Very nice. So number of students, 133. Amount contributed by each student, 133. I'll just write these 2 steps, children. Don't take a screenshot now. I'll just include 2 statements and then you can take a picture.
Ma'am, if I've already written these 2 statements, then is it fine?
Yeah,
I
yeah,
don't
yeah.
have to read.
Yeah. Then you don't have to take a screenshot. Yes, you can check it right away. If you've completed the answer, you can check your answer right away.
Yes, ma'am.
So, you need to write all this first. You need to write all this first. And then at this stage, square root of 17689, you need to perform this long division. You need to write all these steps first and then perform the long division and find the value of X. Once you find the value of X, you can answer the questions. Yeah, children, now it's ready. If you want, you can take a screenshot.
Ma'am, for this sum, I took a prime factorization method, whether it is correct or what?
Sure. Any method is fine. Is it Surya?
Yes, ma'am.
Yeah, any method is fine, Surya. You can use any method. Have you got the same answer using that method?
Yes, ma'am. When I pair it, I got 7 into 9.
7 into
9.
9.
Sorry, 7 into 19.
Yeah. Yeah, you're right. 7 into 19. Yes.
Okay, fine, ma'am.
Yeah. Let me just work that so that if somebody else has done the same method, they can check it. So you can also use the prime factorization method. 1, 7, 6, 8, 9. So 7 2s are 14, 3 remains, 7 5s are 35, 1 remains, 2s are 14, 4 remains, 7s are 49. Again 7. See, we are not using 2, 3, and 5 because this number is not divisible. This number is not divisible by 2, 3, or 5. So you have to take 7. Now again 7. 7 3s are 21. 4 remains. 7 6 are 42. And 7 1s are 7. Now directly 19 because 361 is not divisible by any other prime number. It's not divisible by 11 or 13. So 19 times and 19 ones. So it is 7 square into 19 square. So 7 into 19, which is 133. Very good, Surya. You're right.
Fine, ma'am.
Yeah. Yeah. Next one. Yeah, how many of you finished answering this question? Okay. So this is
Ma'am, half.
yeah. Okay, fine. So you all of you get time to complete this answer. Yeah.
Yes,
I think
ma'am.
another
I'm
5
left
minutes.
with the second and the third part.
Yeah, please. Yes. Yeah, all of you take down this question. If you've already taken down, please work and complete the answer.
Ma'am, I got the answer.
Yes, Shreya, you found AB?
Yes, ma'am, I found AB, area and perimeter.
Very good. What's the length of the side AB?
It's 5.54 meters.
Okay.
That's what I
Now,
got.
okay, fine, children. All of you, please stop working.
Ma'am,
And
even I got the answer.
yeah,
to
what's
all the three.
what's the length of the side AB?
Ma'am, it is 2.24 meters.
2.24. Okay, children. Give a special name to this triangle ABC.
Ma'am,
Give
right
a
angle
special name.
triangle.
Right angle triangle, correct?
Yes, ma'am.
It's a right angled triangle. It's a right angled triangle or simply a right triangle. Okay. Now, what are these two sides called? The two sides containing the right angle. AB and BC are the two sides containing the right angle, right? See here, this is AB, BC. These two sides contain the right angle. The two sides AB and BC, they contain the right angle. And these two sides are called the legs of a right triangle. Have I mentioned this?
Yes, ma'am.
Yes,
Okay.
ma'am.
Yeah. AB and BC, that is the sides in a right triangle. In a right triangle, the sides, the two sides containing the right angle are called the legs of a right triangle. So this is one leg, this is the other leg. Then what is a special name to this line segment AC?
Hypotenuse.
This is the hypotenuse. And which is the longest side in a right triangle?
Ma'am, the hypotenuse.
So the hypotenuse is the longest side in a right triangle. We know that the hypotenuse is the longest side. That is, the length of AC will be the longest. So AB cannot be longer than AC. If you have got AB longer than AC, it's clearly incorrect. We've gone wrong somewhere in calculation, or the idea we've used is incorrect, whatever.
Yes, ma'am. Now I see my mistake, ma'am.
Okay. I think you added, right? Something like 4.24 square plus 3.6 square. I don't know. Something like that.
Exactly what I did. That's exactly what I did.
So how does Pythagoras theorem work? Anantika, because you've got the answer, tell me.
Ma'am, hypotenuse square is equal to the two sides, like
Correct.
first side square and plus second side square.
Yeah, so if you call this one leg and this one the other leg, so you should, it is the square on one leg plus the square of the other leg is equal to the hypotenuse square. So the hypotenuse square always stands alone, either in the LHS or in the RHS, but it stands alone. Okay, so AC square on one side and then AB square plus BC square on the other side. So we say that this is the sum of the squares of the legs, the sum of the squares of the legs, and this is the square of the hypotenuse. And this is how Pythagoras theorem works. You need to substitute here and find AB. So, okay, next question. So supposing this is 8 and this is 10. Tell me, children, what is, we'll just take a simpler question, children, so that all of us understand the sequence of this answer. Let's take a similar triangle ABC, but with different values. Okay, so this is 8 and this is 10. Now, all of you find AB. Tell me the value. What is AB equal to, all of you?
10 square is equal to 8 square plus x square.
So AB square plus BC square is equal to AC square. Correct. Then AB square we do not know. plus BC square is 8 square is equal to 10 square.
10 square.
Yeah, so AB square will be equal to 10 square 100, or you can write 10 square minus 8 square, correct?
100 minus 64.
Correct, 100 minus 64, or 10 square minus 8 square. So AB square is equal to 100 minus 64. AB square is equal to 36. AB is equal to the square root of 36. AB is equal to 6. What if I say centimeter here? It's going to be 6 centimeter. 6 centimeter. So this is how we find AB. Next, in our example, what will be the area of the triangle ABC?
Ma'am,
The example we have taken.
Ma'am, area will be half into base into height.
Okay.
So half into base,
half
which
into
is
base
8
into height.
centimeters, and
No,
height,
name the base.
which is 6
Name
centimeters.
Name the base. Name the base. Name the altitude.
BC.
BC. Base is
BC
BC
into
and altitude
AB.
is AB. Very good. Okay. Then, so in other words, the legs. These are
Yeah,
the
we
legs.
put the values now.
The legs. These are the legs. So half into BC is 8.
6 into 8.
AB is 6.
So we cancel out and then we get 24.
Correct. 24 centimeter square.
Yes.
So, yeah. Then perimeter. How do you find the perimeter? The sum of the three sides. AB plus BC plus AC. AB plus BC plus AC is the perimeter. So that's going to be 6 plus 8 plus 10. 24 centimeter. All right, children. So you'll have to use the same procedure here. Same thing here, except that you need to find the square root. To find AB, you need to find the square root of some value. So we'll see what that is. Please check your answer, children.
Yeah, ma'am, it's correct.
Okay. Very good. So as I said, first you need to apply Pythagoras theorem, substitute the values, and calculate 4.24 square. That is 4.24 into 4.24. Not using the calculator, but you will have to perform the multiplication in the left column in your book. So that is 17.9776. 3.6 squared is 12.96. Then when you transpose, it looks like this. This is the difference, and AB is equal to the square root of 5.0176. You need to find the square root using the long division method like this. Don't use the prime. You can do it using the prime factorization method, but long division method is still easier. Easier meaning you can get the answer in less time. So find the square root of this number by the long division method, and you can see the division ends with the remainder 0. The division ends with the remainder 0, which means the given number is a perfect square. And its square root is 2.24. Its square root is 2.24, which means AB is equal to 2.24. So now that we got AB, we can proceed to find the area of the triangle ABC. Half product of legs. Half base into height is the same. Half into product of legs or half into base into height. Both are the same. Half into product of legs. When it's a right triangle, you can use this phrase product of legs. Half into product of legs. So half into AB into BC, substitute and find the area. And perimeter is the sum of the three sides, which is 10.08. If you have not completed, please take a picture, children. Done? Any questions?
No, ma'am.
Yeah. So this is where we stopped in the last class. I think we did the first one in the class, right?
Yes, ma'am. The first one was
Yeah,
diameter.
Yeah, the first one we completed. We'll continue now. Okay. Okay. So what is the least number to be subtracted? So I was telling you in the last class that, you can expect questions of, these four kinds, which are related, So what is the smallest number to be added to make some number, to make this number a perfect square? A perfect square. Okay, then added can be subtracted also. Then it can be multiplied. It can be divided. So they'll give you a number which is not a perfect square. In the question will have a number which is not a perfect square. So you may have to answer one of these four questions. The number is not a perfect square. So what is the smallest number that is to be added to the given number so that the resulting number, the given number plus that number which is to be added, is a perfect square? The question will have a number which is not a perfect square. Now you will be asked to find the smallest number that is to be added to the given number so that the sum is a perfect square. Type 1. Type 2, you will be given a number. That number is not a perfect square. Then what is the question? You have to find the smallest number that is to be subtracted from the given number so that the difference is a perfect square. This is type 2. Type 3, again, you're given a number which is not a perfect square. You need to find the smallest number by which the given number is to be multiplied so that the product is a perfect square. This is type 3. Type 4, again, you're given a number which is not a perfect square. You have to find the smallest number by which the given number should be divided so that the quotient is a perfect square. So when you divide, the result is called the quotient, right? So that the quotient is a perfect square. Now to answer what is the number to be added or subtracted, you need to use the long division method only. Only this method will give you the answer. Long division method only. To answer what is to be multiplied or by what it should be divided, you have to use the prime factorization method only. Prime factorization method only. See, you can remember like this. What is to be added, subtracted? You need some remainder kind of. We are not going to do anything with the, see, whether we are going to do something with the remainder or not, that's a different thing. The procedure is different. Remember like that I'm saying. How to remember? Something is to be added or subtracted. So you need some leftover, you need a remainder. And remainder you'll get only in long division. Remainder you get only in long division. So if the question is what is to be added or subtracted, perform the long division method. If the question is what is the number by which it should be multiplied or divided, use the prime factorization method. Okay. So number to be subtracted. So we have to use the long division method. You will have to use it. Make a note of this, children. Make a note of this. All right. Okay. I hope all of you have made a note of this. Right.
Yes, ma'am.
Very nice. Okay. So here, let's just go back to this one first. So the if you have to find the least number to be added, we need to perform the long division, and then you will not get zero remainder, children. Remainder will not be zero. It will be something other than zero. Now leave the remainder. If you have to find the number to be added, go to the quotient you've got, write the successor of the quotient, and find its square. That is, find 124 into 124. And that is 15,376. Now this one minus the given number, 246. And that is the smallest number which is to be added. To find the smallest number that is to be added, what you have to do is ignore the remainder. Go to the quotient, write its successor, square it, and you get the product as 15,376. Now this 15,376 minus the given number, this result is a number to be added. So you should remember the method. See, you must remember procedures like a question and answer, you know. What is the function of ribosomes and cells? Or what is the function of mitochondria and cells?
Ma'am, is powerhouse.
Sorry?
Is the powerhouse of the cell.
Yeah. Louder.
Is the powerhouse of the cell, ma'am.
Yeah, it's a powerhouse of the cell. And what about ribosomes?
Ma'am, it is protein, ma'am.
They're the sites of protein synthesis. Very good. Yeah. Ribosomes are the sites of protein synthesis. So like this, when you're asked a question, you have an answer, you have a ready answer. Because you've read it many times and you're kind of memorized. Memorized, not mugging. Mugging is different. Memorizing is different. Memorizing is a skill.
Ma, there is an insect here. Can you come, please?
Sorry?
Please, it's big.
Oh, you're talking to somebody in your house. Please disable your mic, Anantika. So, Anantika, kindly disable your mic.
Mom, it's not like my mouse is not working. Can you unmute me?
Okay. So So like that, children, you need to remember this procedure, with an answer. Like you must ask yourself, what is the method if the given number is not a perfect square? If the given number is not a perfect square and I have to find the number to be added, the least number to be added, what is the procedure? Is the question. And the answer to that is I have to perform the long division and then ignore the remainder. Look at the quotient. I need to square the quotient. That number I get minus the given number. You get a new number. That is a difference. And that is the smallest number to be added. So this procedure, you should just visualize. You must visualize that procedure. Because the working, you will know. See, if you know how to perform the long division, this procedure is not difficult for you. You don't have to practice 100 sums like this. If you know the procedure to go about the long division, then this one you don't have to like work out many sums like this. You know the procedure. So this part is fine with you. So you just need to know the sequence in which you need to answer this question. So what should you do? Perform the square, long division, and then this one, then square it. You get an answer that minus this number given, you get some result, and that is the smallest number to be added. So you should just visualize that answer. You must see that in your mind. You must see that procedure in your mind. So everything, okay, maybe I'll, do that in the library. I'll show it to you and then explain. That will make more sense in the next class. I would have prepared the list of all the questions that you can get from this chapter, squares and square roots. I'm actually working on the library. The thing is, it's only post-COVID that I've started giving online classes. Prior to that, it was only physical. So I did not have any, material, for online classes. So I'm just, in the progress, the work is in progress. I'm still building my online material. I have all my material in written form. I have a material with which, I have a material right from 6th standard to 10th standard, but all handwritten, written by me. It's all handwritten. Now I'm converting all that to Word files and preparing the presentation. So all that work is in progress. So that is why the library is still not ready in the portal. So I'll, enable the contents of this chapter in the library. And then I'll show you. You should know the list of questions that can be expected from this chapter, for any chapter for that matter. You must know the list of questions, the different types of questions that you can get from a particular chapter. And every question you should see in your mind and then visualize the answer. And you can be very good at that only when you've practiced. It's not easy. You cannot see everything in your mind without practicing. You need to practice. And once you're given good amount of time for that, you can definitely visualize things. You can just see the question in your mind added and then see the procedure happening in your mind. You don't have to work anything before the exam. Okay, we'll see that next week when the library is ready. Now, this is the procedure for added. Subtracted, it's all about the remainder. Subtraction is all about the remainder. Perform the long division. Remainder, that is the smallest number to be subtracted. Nothing else I have to say. So this is what even you have to remember. Subtracted, perform the long division. Whatever is the remainder, that is to be subtracted. That's all, finished. So you know this method. Okay, so I want all of you to complete this and try this one by yourself. Work this one. And also try, instead of this number, I'll give you a different number. I'll just get my calculator. Yeah. You may start working this one. Please take down the question and work this. Oh my God. I, by mistake, cleared the question. Children, can I have the number from you?
Yes, ma'am. It's 64,
64,
65,
65.
6.
Correct?
16, ma'am.
Or 16. 64, 65, 16. Okay. Okay. So one of you help me do this long division. Yeah, somebody help me start this.
Can I try, ma'am?
Yes, sure.
So 8 8s are 64. So 8 here and 8 above.
Yeah.
64 over here on the other side and another 8.
Yeah, next step.
Then 65 comes down.
Okay.
After that, you have to write 64 here. So 8, 6, 4, 8.
No, after this, I don't understand. 65 comes down. Then after that,
4, then 1 remains.
no. Aishwarya.
Yes, ma'am.
Yeah. Please continue this.
Ma'am, so I'm a little confused in this step, but I'll tell you what I'm done till. So
Okay.
then it'll be 16, and then we need to put a number when we multiply, it'll be 65, right? Or let's
Okay.
say that.
Yeah.
So over here, I'm confused because I don't know which number would give me a number lesser than 65 here.
0.
Listen, so then it'll become 160, right? 160.
160 into 0 is 10.
Okay, ma'am. Okay.
160 into 0 is 0. Now continue. Aishwarya, now continue.
Yes, ma'am. So then 65 comes down again. So we have to put 16 down.
Then as you told me in the last class, you can add a 0 here like this, and or you can say double the quotient. 80 into 2, 160. Or simply add the digit in the ones place here, so it's 160 again. Then
1 second, ma'am. I'll work on it.
yeah.
Ma'am, can I say the answer?
Yes, Surya.
Ma'am, I took 1604.
7, is it?
No, ma'am, 4. 4. 4. 4.
4, sorry. Okay. 1 second. 4. What's the product?
And I got 6, 4.
1 second, I'll do this. 1604 into 4. 6, 4.
6, 4, 1, 6.
And remainder?
100, ma'am.
So what's the number to be subtracted?
Ma'am, 100 is the least number to be subtracted from 6, 4, 6, 5, 1, 6 to make it a perfect square.
Very good, Surya. Keep it up. Very good.
Thank you, ma'am.
Yes, children. You can ask me any further questions if you have. So if no digit can fit in, put 0. 160 into 0 is 0. Because 1 itself will be too much. 161 into 1 will be 161. But the number here is 65. So then you have to take 0. 160 into 0 is 0. And then bring the next pair down. Okay, let me work it again for you. 646516. 66516. 646516. Okay. So we need to pair from behind like this. 8 8s are 64. 0 is a remainder. Bring the next pair down. Double the quotient. Double the quotient and place that number here. Next, whatever digit you place here, you must place the same digit here. If you take 1 and 1, 161 into 1. 161 into 1 is 161, which is more than the number 65 we have. So you have, because if you can't take 1 is the smallest number, if 1 itself is big, then you have to take 0. There is nothing smaller than that. You have to take 0, 0, 0. So this means 160 into 0 is 0. So 160 into 0 is 0. Remainder 65. Bring the next pair down. Double the quotient. 80 into 2. Double the quotient. 160. Place it here. Whatever digit you place here, you must place it same digit here. And when you work, you find it's 4. 1604 into 4. 1604 into 4 is 6416. And the remainder is 100. And we start the division here because that's all. We've got all the pairs down. There is no part of the number given which remains here. We have brought 65 down, 16 down. So we're done with the division. So 100 is a remainder. Now this is the smallest number that is to be subtracted from the given number to make it a perfect square. Take down, children. If you haven't done this correctly, please take down the answer and complete it like this. You cannot just do the division and leave it there. You must write this comment.
Done, ma'am.
All right. Yeah, this is the next question. Which is the greatest 6-digit number that is a perfect square? You need to find the greatest 6-digit number that is a perfect square. We all know that the greatest 6-digit number is this one. But no, this is not the.
We have done this in one of the homework, same question.
Okay, then we'll take 5 digit. Then we'll take 7-digit number. Oh, 7, not 7. Okay. Okay.
I
5
think
digit
these
number.
questions were given as homework class.
Okay, let me change the question. I'll change the question. Let me make it 5-digit number. Is that okay?
Yeah, ma'am.
Let me change it to 5-digit number. So if you have to find the greatest 5-digit number that is a perfect square, the greatest 5-digit number is this is the greatest 5-digit number. This is not the question. The question is not which is the greatest 5-digit number. The question is which is the greatest 5-digit number that is a perfect square. That should also be a perfect square. It should be the greatest 5-digit number that is a perfect square, not just the greatest 5-digit number. So for this, what you have to do is you will have to take up the greatest 5-digit number and perform the long division. Perform the long division. Whatever is the remainder that should be subtracted. See, in simple words, you should use a subtraction procedure here. You must use a subtraction procedure here. So you get a remainder. You must subtract that. Now, supposing, for example, children, 1 is a remainder. So 99999 minus 1, 99998. So this is the greatest 5-digit number. That's a perfect square. I'm just telling you the procedure, depending on the remainder. So to find the greatest number, the greatest, maybe 5-digit, 6-digit, whatever number that's a perfect square, you should take up the greatest 5-digit number and perform the long division. Use the remainder that is obtained. The remainder that is obtained is important. Subtract that from this number, and the remainder is the required greatest 5-digit number. So here I've done for the 6-digit number, children. So you can do for 5 now. So see here, the method is a subtraction method. That procedure. Take up the greatest 6-digit number. Perform the long division. The remainder is 1998. So this number minus 1998 is 9,98,001. This is the greatest 6-digit number. That's a perfect square. So it's just a subtraction method. See, if the question is what is the smallest number to be subtracted? If the question is what is the smallest number to be subtracted, you will say the remainder has to be subtracted. Now this is one step more than that. This is a step beyond that. Now here you need to use the remainder. Subtract this from this number. So 9,99,999 minus 1998 gives you this number. And this is the greatest 6-digit number. That's a perfect square. So greatest means you should use a subtraction procedure. Greatest, you should use a subtraction procedure. If you've already worked this, or if you worked this, was it a homework question or we did the same sum in the class? Did we work the same? Was it a homework question?
Ma'am, last class you said that you guys should try to do this by Wednesday, so I think it was counted as a homework question.
Okay. Fine. All right, children. Yeah. If you have not worked it, please write down, work this answer now, and then take the next question. This is the next question, a test question. See, if you have not completed this, please complete this answer and then try the test question. Yeah, children.
Copy it down, ma'am.
Done, ma'am.
Done, ma'am.
Finish the test, ma'am.
Students, give me 2 minutes. I've just got a call. I'll just get back in 2 minutes. Yeah, sorry and thank you, children. Can I have the answer to this question?
Can I say?
Yes, Shreya?
So 99, 99, both of them get paired up, and the first 9 stands alone.
Okay. 1 second.
Ma'am,
Yeah, this one stands alone. Yes. Continue, Shreya.
Then 3 and 3. 3 3s are 9, so 9.
Okay.
Then 6 comes onto this. 6 comes here,
Yeah.
and 1 the quotient, and
No,
99 will come down first,
Hmm.
and 1.
Okay.
Then after that, 2. So
No, here
62.
61, right?
Yeah, sorry.
What's the remainder?
Yeah, 38.
And then 99
Three-
comes down.
Yeah.
Yeah.
And then 62, and the last one will be 6.
6, huh? 6 6
Yes.
36, 3 carried over, 5 1 carried over,
And 5
37.
6.
Correct?
So the remainder is 143.
143. Okay, so what do you do with the remainder?
You have to subtract it.
Minus 143.
Yes,
Yeah.
ma'am.
What's the remainder? Meaning after subtracting, what do you get? What's the new number you get?
I get 99,856.
Very good, Shreya. Very, very good. So finally, you got the long division method, right?
Yes, ma'am, after a lot of practice.
Very good. See, that's what is important. See, see, I can repeat it 2, 3 times, but if you don't practice, that method is not going to be registered in your
Yes,
mind.
ma'am.
You need to
Mhm.
practice. Yeah, you did it. Very good, Shreya. Yeah. Yes, children. So she's right. This is the answer. The required 5-digit number, that's a perfect square, is 99,856. Correct? All of us get that?
Yes, ma'am. Yes, ma'am.
Very nice.
ma'am, if they ask us the smallest,
Huh? Come again?
what if
The
they
question.
ask us the smallest?
Yeah, that's the
6
next
digit.
question. No. 1 minute. That's the next question. We'll do that.
Okay, ma'am.
See here. See the next question. Yeah. Is this done, children? All of you finish this one?
Yes, ma'am.
Okay.
Yeah.
Now see this question. Which is the least 6-digit number that is a perfect square? That is the smallest. You'll have to find the smallest 6-digit number, which is a perfect square. The smallest 6-digit number, which is a perfect square. So which is the smallest 6-digit number?
1 lakh.
1 followed by how many zeros?
5
Ma'am,
zeros.
can we do this question on our own?
No, but I haven't. See, maybe you've learned it in school, but I have not introduced this question in the class. So maybe we'll do this and then I'll give a different question for you to try by
Okay.
yourself. Yeah. So this one is the other one, children. The procedure, the long division method and the other procedure, the number to be added, that method. So you just have to find the square root of the smallest 6-digit number using the long division. It is not a perfect square, so you will not get remainder 0. The remainder will not be 0. The remainder will not be 0. Supposing the quotient is, supposing it's like some 315. Okay, so you just have to take the successor, 316, square it. And that number, whatever you get, that number is the smallest 6-digit number. That's a perfect square. So see here. So we know that the smallest 6-digit number is 1 followed by 5 zeros. So perform the long division. This number is not a perfect square, so we will not get 0 as the remainder. You need to continue the division process till you bring down all the pairs. So once all the pairs come down, then the division comes to an end. The division will not come to an end with a 0 remainder. Here, the remainder is 144. We stop here because we have no more pairs to get down. Now look at the quotient. We have 316. The successor of 316 is 317. And 317 squared is 1,489,000. And this is the smallest 6-digit number that is a perfect square. All right. Now you will not have this question. They will not ask you to find the smallest 7-digit number, which is a perfect square, because the smallest 7-digit number itself is a perfect square. What is the smallest 7-digit number? 1 followed by 6 zeros. 1 followed by 6 zeros. And this number itself is a perfect square. The smallest 7-digit. Can I complete, Anantika? The smallest 7-digit number is 1 followed by 6 zeros. And this number itself is a perfect square. What is the square root of this number? The square root of 1 is 1. And this number has 6 zeros. So from 2 zeros, 1 zero out. For see, not like that. It's not like 2 zeros, 1 zero out. So like we have 6 zeros here. So half the number of zeros will come out. Half the number of zeros. So 3 zeros out. So the square root of this number is 1000. 1000. So the smallest 7-digit number itself is a perfect square. So this question cannot be asked. So then we will find, the test question is find the smallest 8-digit number, which is a perfect square. Complete this one. And the test question is?
Mom, can I ask a question?
Yeah, sure, Anantika. Now, yes. Yes,
Yeah.
Anantika.
So if you get 317 square, then you should also find the decimal places, right?
Decimal places. 317 square is 317 into 317. No, I don't understand. Decimal places where?
No, like the answer that you got is 316. How did it turn into 317?
You have to take the successor of the quotient.
But the successor will be decided if the decimal's next number is 5 or greater than 5. And if it's less than 5, then it will remain as the same number, right?
Okay, 1 minute. The successor of 360. I'm not rounding off. You're getting confused with rounding off and successor. I'm not rounding off. The successor of 316 is the number that comes after 316, which is 316 plus 1, 317.
Mom, yeah, I got it, but like the question is that.
No, you please ask me till I understand.
317.
No, I don't understand your doubt. You ask me till I understand. I don't understand your question. See, 316 is the quotient. You need to take the successor of 316, which is 317, and square the successor. So 317 squared is 1,489,000, and that is the smallest 6-digit number, which is a perfect square.
Ma'am.
No, Anantika, please ask me. No, I don't. I'm sure you still have a doubt.
Now it's clear.
Okay. All right, fine. Yeah, it's time, children. So all of you take a screenshot and complete this, and also finish the test question. We'll see the answer in the next class. Take a picture, all of you.
Ma'am, I'm
Yes.
almost
Ma'am,
done.
I've done
with
the
test.
sum, so we'll discuss it next class, right?
Yeah.
Okay.
Ma'am, I'm almost done with my test answer, ma'am.
Okay, fine. Anantika, but since you told me first year, what's the answer, Anantika? Let's see if both of you are getting the same answer. Anantika, what's the answer? Okay, Shreya, what is it you got?
Just a second, ma'am. I'm not done yet.
Oh, no. Okay, since it's time, no, in
Ma'am,
that
it
case,
is
we'll see the answer.
3162, and if we take the successor, it will be 3163.
Okay, 3162 is the quotient, and the successor is 3163.
Yeah.
Yeah, ma'am. I just need to add that too. Yeah, I got it right then.
Yeah, and it's right. Yes.
I just couldn't.
3163.
Yeah, I couldn't unmute myself.
Yeah. 3163. So what's the square? What's the square of 3163? Because we need to find the smallest 8-digit number. What is that 8-digit number? Working on that, is it?
Yes, ma'am.
Okay.
One second.
Ma'am, I have a small doubt.
Yes, Surya, please ask.
Ma'am, in the greatest 5-digit number, why we are subtracting the remainder minus, the quotient minus the remainder? In the case of least 6-digit number, why we are finding the square root of the quotient?
Not the square root, the square of the quotient.
Yes, ma'am.
Okay, see. It's a procedure, and you are questioning the procedure now. Is the procedure giving you the result?
I think so, yes.
The procedure is giving you the result. So you need to remember the procedure.
Okay, fine, ma'am.
The procedure is giving you the result. So we have to remember that procedure. Now, if you have to find the greatest number, then whatever is the remainder should be subtracted. If you have to find the smallest number, then you'll have to take the successor of the quotient, square that, and that is the required smallest number. So remember the procedure. That's why I told you. That's why I told you you must remember every procedure like a question and answer. You must ask the question and answer it. That's how you remember these procedures.
Yes, ma'am.
Ma'am, I think I got the answer. It's 9981031.
No, no, no.
Ma'am, is it 8 crore itself? Like, sorry, is it 1 crore itself? Like those 8 numbers?
No, no.
Like
All
one,
right, children.
zero,
No, fine.
1,000.
So we'll postpone the discussion to the next class. Anyways, thanks for your like the earnest and or the interest to complete the answer in this class. Nice, Anantika and Shreya. Anyways, we'll forward this to the next class. All right, children. So that's it for today's session. Thank you so much. Good night. You may leave the call.
Thank you, ma'am. Bye,
Ma'am, I
ma'am.
got the answer. Can I say?
Yeah, thank you, children. Yes, Anantika,
Ma'am,
what's your answer?
1000, then 4569.
Correct. Yeah. 1, 3 zeros and then 4, 5, 6, 9.
Yeah.
Correct. Very good. Good night.
Yes, ma'am.
Thank you, children. Good night, children.
Bye,
You may
ma'am.
leave the call. Yeah.
Thank you, ma'am.
Thank you. Good night.